Hi and welcome to our video about liquefied natural gas, LNG, liquefaction technologies and process. LNG is a natural gas that has been cooled to 162 degrees Celsius, at which point it becomes a liquid and can be transported more easily and safely than in its gaseous state. The process of converting natural gas to LNG involves several steps, including liquefaction, storage, and transportation. The first step in the process is the removal of impurities such as carbon dioxide, water, and sulfur. Next, the natural gas is compressed and cooled to a temperature of around 120 degrees Celsius. At this temperature, the natural gas condenses into a liquid state and is then further cooled to 162 degrees Celsius, which is the temperature at which it can be transported. There are several different technologies used for LNG liquefaction, including the propane pre-cooled mixed refrigerant (C3) (MR) process, the cascade process, and the dual mixed refrigerant (DMR) process. Each technology has its own advantages and disadvantages, depending on factors such as the size of the LNG plant, the desired capacity, and the availability of resources. In the propane pre-cooled mixed refrigerant process, the natural gas is cooled using propane, which is then recovered and reused in the liquefaction process. The cascade process uses a series of refrigerants in a cascade fashion, with each refrigerant cooling the next. The dual mixed refrigerant process uses two refrigerants that are mixed and circulated to cool the natural gas. Once the LNG has been liquefied, it is stored in large tanks or vessels, ready for transportation to its final destination. The LNG is transported in specialized ships or tankers, where it is kept at a temperature of around 162 degrees Celsius. In conclusion, the liquefaction of natural gas to produce LNG involves several steps and technologies, including the removal of impurities, compression, and cooling. There are several different LNG liquefaction technologies available, each with its own advantages and disadvantages. However, regardless of the technology used, the end result is a highly versatile and valuable energy source that can be transported easily and safely to meet energy demands around the world.